Brian Wisniewski, and I am the data visualization specialist here in the Research Commons. A little bit about myself, just some background. I went to Ohio State, studied philosophy and math, more math than philosophy. And then currently I'm finishing up my master's degree in translational data analytics here at Ohio State. And so today we're going to be talking about R. So this is the introduction to R for data visualization. It's kind of the follow-up to the introduction to data visualization that if you were in attendance last week or in a prior session, this kind of hopefully builds off that to some extent. And then in the future, the goal would be to then offer an intermediate level version of this, which gets more into the weeds. So just some preliminary agenda setting here. So we're going to move through a couple different things here. So what is R? Why you would want to use R? So some pros and cons. And then we'll move into some overall layout and terminology so that we can all speak the same language. You don't need to know very much about computer programming to get started with R, but you need to know a little bit of the language so that you can Google questions and understand the documentation for some of the data visualization methods. So it is important to know some jargon. And then we'll set up the environment. I'll run through some examples in an environment and kind of show you what this stuff actually looks like in practice. So my goal is to try to get through the slides as quickly as possible because it's a little bit boring and less useful to you probably than seeing some practical examples actually in real time. So that's kind of the objective here. And then, so yeah, we'll create some visualizations and we'll practice on a sample data set. So, and if I don't answer your questions, I can't see them. So we'll try to get through the questions at the end. So what is R? So R is a free software environment for statistical computing and graphics. So effectively what that means is it's a computer programming language that's especially useful for statistics and mathematics. So maybe that's a little bit of a reductionist definition of what a statistical programming language is, but for functional purposes here, that's pretty much the difference. It's just a computer programming language with a little bit more capacity for that high-end statistical analysis. 9 times out of 10 as a beginner, you're probably not going to tap into that statistical capacity in practice. You're just not going to have the need for it, but it is nice to have that. It's also the syntax or the grammar of the language, the way that the language is structured, in my opinion, tends to resonate with people who are more mathematical minded. I think that's just been my observation personally. So I want to show you a couple things here before we begin. So we have, oops, we have nothing. Moment. There we go. So Shiny is what's called a library. So a library is, and we'll get into this later in the presentation, here's an example of that jargon I was talking about. A library is basically a collection of tools that we can use to accomplish some objective or set of objectives. And so our Shiny is one of those toolboxes, one of those libraries, and it's primarily used for, well, easy web apps for data science without the compromises. So it's used for web-based applications and specifically for creating visualizations and hosting them in a web browser. So you can do this in R, obviously, but you can also do it in a programming language called Python, which you may be familiar with. So I'm going to go to the gallery here just to show you exactly what can be produced with this. So for example, you can create dashboards. So in this case, this is a bus dashboard, which presumably is showing various paths that there are that one can take on the bus in this particular location. So you can see the different routes for the buses and whatnot. And so I don't want to spend too much time here in R-Shiny because I think that's more appropriate for an intermediate or even advanced level R user. But I just want you to be aware that if you have that need in research or in whatever professional capacity you're working in or academic capacity you're working in, for a visualization or a set of visualizations to be hosted in a web browser, in a web application context, this R-Shiny library is kind of the gold standard to do that. And if you can create the visualization, you can host it in the web browser with R-Shiny. R-Shiny is effectively a way for the R code to it's a way to communicate with a server, a web-based server, and host visualizations. So I'll allow you to kind of explore this at your own leisure. I don't want to get too far into the weeds here today, but if you're interested in how any of these examples in the gallery work, you can view the code and download that code and open it in your environment, or you can presumably look at it in the web. And additionally, on this website, there are articles for learning R-Shiny and strategies to deploy R-Shiny in a production setting if you're working in an industry or something. And there's just an array of resources on this site if you're looking for that. But really, the takeaway here is that this exists as a mode of web application hosting for visualizations. And this other link is much more practical for a beginner. This website is called the R-Graph Gallery. And what this is showing is somewhat similar. If you attended the Intro to Data Viz workshop, you'll remember something that looked a little bit similar, a website that looked very, very similar. So it's the same exact concept as that, if you recall that. So we can see various visualizations that are listed here, broken down by what their primary purpose is. So ranking versus correlation versus distribution. So for example, let's say we would like to show a box plot. We can go ahead and go into that box plot. And we can see the breakdown of what exactly the visualization means. And then we can look at various ways of depicting that visualization in R. So I clicked on a basic box plot because that's probably 9 times out of 10 what a beginner is going to be trying to accomplish is a beginner level visualization, nothing super advanced or sophisticated. So all of this mumbo jumbo here, this is R code. So this is what's telling R to create a visualization. So you can go ahead and if you were on this website and you had R set up, you can literally just go into R and copy and paste it, and it will create an example for you. And you can go in line by line if you'd like and try to tailor the example code to fit your specific needs. Or if you're interested, you can try to understand what each line of code is doing. But the purpose here is you can get an example up and running and see how that visualization is created in its most basic capacity. Just for a piece of tertiary information here before I proceed, all of this up here is not creating the visualization. So these are taking, this library function is bringing in those toolboxes that I was talking about. So in this case, there's one called the Tidyverse, Viridius, and this HRB themes. These are just to get the tools into the environment. This right here, creating a data set, this is just defining a fake data set, a dummy data set, so that we can visualize some data. So it's just defining some arbitrary data. And this down here is actually what's doing the heavy lifting and actually what's creating the visualization. So we'll get into more of what any of this means towards the end. I don't want to overwhelm you, but just know that this is our code and that this is actually what's creating the plot. This is preliminary. So You can create animations using R. So if you have, in this case, we can go here. If you have GDP per capita, for example, and life expectancy, and you want to see how, and the location, continent, and the population statistics here, you can see how those things vary as a function of time. So you can see right here, this year count is increasing over time, and we can see how the data is changing accordingly. So you can probably understand the power of this. So what are we showing here? We're showing GDP per capita, life expectancy, population, location, and there's a temporal component to this. That's 5 dimensions in one visualization. Very powerful. So you could create something like this, and obviously, because this is dynamic, it's changing over time, you can't really represent this in a static capacity, i.e., you can't print out a animation, but what you could do is you could host this in that R Shiny web-based application and have a internally hosted web application through OSU. OSU has some server hosting capacities, so you can host this visualization and website and create, represent your research in a way that is more dynamic and interesting, rather than just creating a paper and having a static visualization. Same as before, what I was getting at with the examples, you can do the same exact thing with these interactive visualizations. Sometimes it's a little bit finicky and may not work, and it also takes a couple seconds to get rendered. But something like this, as you can see, this is a great example of why someone would want to use R rather than using a simpler tool like Excel or a website. There's a lot of websites that you can create data visualizations. This interactive visualization is probably, I don't want to say impossible because I'm not an Excel expert by any means, but I would say if it is possible, it's probably not very easy. So we can go back. So you can see we now have this this dynamic visualization in this environment, and the actual code is not very complicated. So all of this hard work, all of this that looks like it would take a lot of hard work, really doesn't take very many lines of code to produce. Why? Because we have these libraries that keep things nice and neat and tidy and consolidated. And so a lot of the heavy work that normally would be on your shoulders has been outsourced to those libraries. So this website has, again, like the other website I showed you, it has a bunch of things that you can go, a bunch of facets that you can go down and look at. There's rabbit hole upon rabbit hole on this website. There's base R. So base R is the programming language. Base just means its most basic form. So this is just the program about the programming language R. ggplot2 is a library that is for data visualization. It's the gold standard bread and butter data visualization library, one of them. Interactive charts, self-explanatory. And R Markdown is something, R Markdown is a facet of R that creates documents. So if you have a bunch of R code and visualizations, R Markdown is the method internal to R that creates things like PDFs and Word documents. So it packages all of your code and visualizations in nice, neat forms. So that's what R Markdown is. So why would you use R? So R provides a wide variety of statistical and graphical techniques and is highly extensible. Hopefully I've proven that to you a little bit with those examples, that it's highly extensible. So there's any visualization that you can imagine more than likely is going to be able to be created in R. R is highly customizable. So that's the advantage over more rudimentary and web-based tools, or like I said, things like Excel or even Tableau. So some other pros, it's free and open source, so it's completely free. So to actually do things in R, you're going to need to download the language R, but you'll also need an environment to program R. So I'll get into this later, but you would need R and something like, for example, what's called R Studio to program in R. And both of those are completely free, no strings attached. And open source just means that the backend code that makes those environments function is open source, and the actual backend for the programming language is able to be manipulated by the user. But that's way more. It doesn't matter for a beginner level. It has absolutely no bearing on you. Just focus on the fact that it's free. Statistical language, talked about that. So it's very good at high-level statistical analysis. So it's, in particular, machine learning. So if everyone's talking about AI, artificial intelligence, well, a facet of artificial intelligence in the data science world, we would say it's machine learning. It's teaching machines to learn. And what machine learning is, in effect, is really just statistics at the end of the day. And so R is very good for things like machine learning. Facilitates data wrangling. So data wrangling is exactly what you would imagine it would be. So if imagine wrangling anything, it's to ascertain control over something. It's wrestling with something to gain control, to gain the upper hand. Data wrangling is a combination of things, but it's effectively in practice taking hold of your data by cleaning it and making sense of it, removing data entry errors, and structuring it in a form that can then be understood by your programming language, in this case, R. It's popular in research in certain industries. So R is extremely popular in academic circles because it has a long-standing intellectual history. It's very old, it's tried and true, and it creates very simple, aesthetically pleasing visualizations. And it's quick and dirty, and that tends to be pretty popular with academic types. And certain industries use it, though it's tended to be replaced, at least from what I've seen, by Python and BI, what are called BI tools. So, for example, Tableau, if you're familiar with Tableau, some of these more modern tools are easier and more efficient to accommodate the needs of industry, which tend to be potentially a little bit less sophisticated than research needs, which you may need that higher end statistical analysis, for example. It's flexible, so it's good for standalone analysis and can be integrated with other languages. So what I mean by that is it can be used on its own in terms of it can do everything that you need it to do. It can do the data wrangling, it can do the visualization, it can do it, everything that you could ever need to do pertaining to data visualization can be done with R. Whereas with other tools, i.e. Tableau, you may need to invoke multiple tools to accomplish the end result of having a cogent data visualization. So you may need to perform the data wrangling in Excel or some other environment and then import it into Tableau. So now you have multiple tools. Whereas with R, you can do everything that you need to do all in one place. It's a one-stop shop. And because it's so old and very popular, it tends to be able to be integrated with more modern languages. And what I mean by that is it's compatible in terms of you can take R code and integrate it into systems that are built with more modern programming languages. And there's a variety of ways to accomplish that, but that's beyond the scope of this workshop. Our community offers resources and help. So it's, like I said, it's an old community. So it has a very dedicated user base because it's old and extremely useful, and it's just been around so long that you have these people who have been using this for 20, 30 years, which other programming languages, you may not be able to find folks with that much experience. So it's a very rich community. And if you start looking, you will stumble upon a community. Both those websites I showed you had a blog facet to the website. That's a community aspect element right there on each of those websites that you could go and engage in question asking and various forms of help seeking. So ggplot and plotly packages make clear, aesthetically pleasing visualization. So these are both libraries, plotly and ggplot. Plotly is another gold standard bread and butter data visualization package. I prefer ggplot because that's what I learned when I learned how to do this stuff, but plotly is also very good. So it's not all fun and games. There are some negatives to R in a relative sense to other tools. It can be unintuitive to beginners, challenging to learn. Because it's so old, more modern languages, things are abstracted out. So the language is written in a form that takes some of the burden off of the programmer and places it on the compiler, or the language is just a little bit clunky. I'll put it that way. So it's old. So as I just said, many packages are outdated, not maintained. So there is a graveyard of libraries that have been created over the decades that this programming language has existed. And some of the creators of those libraries gave up on their libraries, but they're still out there. And if you're not aware that some of these packages could be outdated, you may run into compatibility issues, and you may run into just various headaches that go along with using outdated packages that are not maintained. So you just have to be cognizant of what packages and libraries you're invoking. Generally, it's probably not going to be a problem. If you're using the mainstream packages that are recommended for data visualization, you're not going to run into that as an issue. But if you're digging through older libraries, you could run into some compatibility issues and things like that. So it's not ideal for dynamic or 3D visualizations. That probably doesn't really matter in an intro level workshop. And it's not maybe strictly speaking true. I think it would do just fine for both of those purposes for most people. It's slow. Other languages are faster for big data, i.e. Python. So slow is a relative term. It's not going to be noticeably slow in most cases. When we're talking about big data, we're talking about big data. We're talking about millions upon millions of rows of data. Then you're going to start noticing differences, and that's going to matter at very large scale data processing. So think corporations who are processing millions of records. Then we can start talking about speed. But for the average person, you can ignore this. It's not going to matter to you. Most likely, it's probably not going to be noticeable. And maybe several seconds or milliseconds difference. I mean, this is pedantic. It doesn't really matter that much. More memory, also pedantic. Who cares? I mean, unless you're processing a lot of data, it's not really going to matter. But just for your own edification, these 2 points are related. So it's slow, and that's in relationship to how it uses memory. So the way that the language is interfacing with the computer memory is what's causing it to be slow. It lacks basic security. Also, almost all of these are pretty pedantic. I'll be completely transparent with you. Probably doesn't matter. I wouldn't even worry about it. But lacks basic security, suboptimal for certain use cases such as web application embedding. Who cares? It's pretty much good. It's pretty much good enough. Okay. A lot of the exploits that existed 5 years ago have been fixed, and it's constantly being updated. And it's if you're running into a security issue at this level, I think your IT department needs to step up a little bit. Overall layout and terminology. So this is what I was talking about as far as the jargon's concerned. So we need to all speak the same language, so you know what I'm talking about. So an object is a name that you can use to call up stored data. So I'll give you an example. Let's say you have X. That's your object, and we set X equals to something. Let's say X equals 5. X is the object, and it's when we reference X, we are referencing we're referencing 5, which is stored in that object. So in reality, what's going on there is the variable X is actually pointing to a place in memory, and that place in memory is storing some value, which is in that case 5. So an object is just an object. It's an item. It's a data point. It's whatever you want. It could be a list. That could be an object. It could be a collection of data points. I'll show you in practice what I mean by that. A function is a self-contained modules of code that accomplish a specific task. So if you imagine a recipe for baking a cake, that list of instructions to create the cake, you could consider that a function, right? We could call that a cake baking function. So it's just a set of instructions to produce something. So if you want to stay with that, I don't want to talk about math too much, but if you imagine y equals mx plus b, we have a function. Mx plus b produces some output, that's y. That's an example of a function, but a function can also be a series of steps, as in with the cake baking example, put your egg in your flour and mix. There you go, you have a function. Package, pre-assembled collections of functions and objects stored on your hard drive. So we take a bunch of these functions and a bunch of these objects, and we say, hey, these are very useful for some common purpose. Let's put them in a big package. Let's package them together, group them together in a box, and have that set aside so that anytime we want to accomplish some set of objectives, instead of having to go find each object and function that we want, we can just go get that whole toolbox and bring it in and accomplish the objective more easily. So, for example, I keep talking about this thing called ggplot. ggplot is a package of objects and functions that people realized are very useful in conjunction with one another for creating visualizations. So it's used to make life easier in that way, instead of having to go out there and find each individual function for your use case. And then library basically is the same thing as a package. In this case, there's differences, nuanced differences, but as far as the world of R, if you hear library, they're talking about a package. And if you hear package, they're talking about a library. It's effectively interchangeable. So when you actually open the environment that you program R in, which is called RStudio, this is what you'll see, and I'll show you that in a few minutes. I'm just going to flash this on the screen, run through it very quickly. In the upper left here, you have this source pane. This is where you can actually write code. In the lower left, you have the R console pane, where you can actually execute commands. In this lower right, you have this plots, packages, and help pane, which has various functionality, i.e. the ability to view plots that are created when you execute code here in the console. You can look at packages. So this is a place where you can find new packages or view the packages you already have. So if you need to go get more of those toolboxes, this is going to interact with the internet, and you can bring it in from the internet by using this pane right here. And then there's a help pane where you can get help. Let's leave it at that. I'll show you that when we get there. And then the upper right, you have the environment pane, which shows overviews, objects, data sets, parameters, etc., that you have imported or created. So as we're defining objects in the console here, it will start to list them up here so that we can keep track of what's been defined. And so to actually set up R, as I said before, you need really two things. You need R, and you need an environment to program R. I would recommend for that environment to use what's called R Studio. And if you go to this link, which will be included in the material we send out afterwards, you can just go right here and see a link to download R, and then the link to download R Studio. And there's some documentation on there to help you get up and running. It's not terribly difficult, but it does take a little bit of effort to get up and running. Maybe in total 10 minutes if you're following a tutorial. For example, this tutorial, which again, we'll send out all of this. So you can go to this link right here and get a start to finish tutorial on how to set it up on Windows or Mac or Ubuntu if you're an Ubuntu user, which I don't know who's an Ubuntu user, but so that's me, and this is some other stuff. So now we're actually going to show you what even R code looks like and what R Studio looks like and what I've been talking about for the past half hour in practice, because this is the type of stuff you have to do to learn. You can't hear someone talk about it and really get very far. It's just not the way it works, at least not in my experience and experience of people I've spoken to on this stuff. So when you open R Studio for the first time, you'll see something somewhat similar to what you're seeing here. It won't look as cool because I have a custom color scheme. Yours will be boring and white. Mine's cool and mysterious and reminds me of the Matrix. So that's what I like to program in, but you can change the color scheme and the theme. But so this is what you're going to see, something like what you're going to see. And so the first thing you're going to do is go to Tools, and then you're going to go down to Global Options. And you're going to do a couple things here. The first is this R version right here. This file path needs to be wherever you downloaded R to. So you're telling RStudio, hey, I saved R when I followed that tutorial. When I followed that tutorial and I downloaded R, I saved it here so that RStudio can go talk to the R language and actually execute code. So this is very, very important. And then this other thing called the default working directory. So a working directory is a place on your computer that you want to save files, import and export files, basically. So in this case, I have it in some random folder, but you can go ahead and change that to whatever. So in this case, mine's this PC desktop, and then I have some random folders I made. It's just a folder. So create a folder on your computer that you want to keep files in, and that's really what that is. It's that easy. So you can apply it and then hit OK. And once you do that, you'll know you did it correctly if you go to this Files tab right here and you see the working directory right here. And anything that's in that working directory, you'll see all those files listed below. And so if you had a Excel file and you want to work with it and you saved it in your working directory, it would show up down here. So in this case, here's an Excel file for Bigfoot sightings. You could just go ahead and click it and then press import. if you're on Windows, left click it. It'll flash it up on the screen so you can see if it's the Excel file that you want. And then you can either copy and paste this into your console, or you could just press import. And boom, now it's inside our studio, it's inside the environment, and it is saved in an object called BFRO reports geocoded. So this right here is the actual code. So it just executed the code for you. So it's using this function. Remember, we talked about functions called read CSV, and then the file name. And it looked in your working directory to try to find something named BFRO reports geocoded.csv. And then it put all of this information inside of this object. This little arrow here is telling R, I want to take anything on the right side here, and I want to put it inside this thing right here. So now if we look at it, if you don't believe me, we can call it down here and we can see it. So now it's in the environment, and we can go ahead and start doing things with it and go from there. And you can see that in the upper right here, in this environment pane up here, we can see that in the environment, we have an object listed here called BFR reports geocoded, which is what I just imported. And it's got 5,000 rows with 28 columns. But anyway, that's boring. So this is the actual code. So I'm going to run you through kind of line by line as quickly as possible, because we don't have too much time here. And I'm going to try to give you some background and not overwhelm you, which is a little bit of a tightrope walk. But just bear with me. If anything, just take it as proof of concept that this stuff is real and that you can actually do it. So the first thing I'm going to do is I'm going to tell R that I need a toolbox, and I want to take the toolbox called Tidyverse. So I already installed this library here, but if you didn't have the Tidyverse, there are two ways you could do that. You could go to the packages pane here, and you could search for it right here, and you could just go ahead and click it, and you could install it through this packages pane here. Or I like this better. There's a function called install.packages, and you can do a single quote, and then you can just type whatever it's called and press enter, and R will go to the internet, and assuming you're connected to the internet, and it will find it wherever it exists in the ether and pull it into RStudio and download it for you and do everything for you, as long as you spelled it correctly. And spaces do matter. So if you do Tidyverse space, that's different. It's not going to find it. It's got to be exactly just one word, Tidyverse. And if you need help with any function, including the install.packages function, you can just write a question mark before any function, press enter, and in that help pane that I was showing you earlier, it'll just pull in all the documentation that explains what that function is or what that particular object is. And you can, instead of going to Google and writing what is this function, you can just do it this way, and it will do the work for you and bring it in here so you can read about it. So anyway, after you've installed a library, you have to tell R that you want to use it now. So the way we do that is there's a function called library, and we can just literally type whatever library we want to use. In this case, we're going to use the library Tidyverse, which has a bunch of other libraries in it that are useful for data visualization. So I keep talking about ggplot. I've said it probably 6 times at this point. ggplot is inside the Tidyverse. The Tidyverse has a bunch of libraries. It has ggplot2, one called dplyr, which is really useful useful for data wrangling. I talked about data wrangling at the beginning. dplyr is the core package for data wrangling, and ggplots for the visualization. All of this other stuff, read R is to read in the CSV files, and then all this other stuff, don't really worry about it. Forcats, per. There's a bunch of packages in here, but these three are kind of the trifecta here that we care about in this case. So we want to then use a function. We want to tell R that we want to use a function in the ggplot library. So in this case, we're going to tell it, hey, I want to do something using ggplot. So I'm going to write ggplot, and then, well, what do I want what do I want to manipulate? What am I even doing? Well, I want to work with data. Okay, and so in this case, there's a data set that comes with R called the MPG data set. And so we can tell it, hey, I want to work with this data set, MPG. You could just as easily write that BFRO reports geocoded. You could write whatever data set you have. But in this case, we're going to use MPG. So when I run this, it does nothing because I didn't tell R to do anything. All I said is, hey, R, I want to use ggplot, and I'm going to be talking about this data right here. R says, okay, I'm listening. You didn't tell me to do anything. You just told me that you are going to do something. So I'm going to tell it to actually do something. So I want to create a scatter plot. In the ggplot universe, the tidyverse universe, the ggplot library, we call scatter plots geom points. Why? I have no idea, but it's called a geom point. Well, it's because well, who cares? So it's called a geom point, and we want to do something called mapping an aesthetic. Ooh. So what is mapping anything? So mapping anything, you imagine you're taking something and you're mapping it onto something. And an aesthetic is a visual component to something. If you think about what these words mean, so mapping an aesthetic, let's map an X aesthetic and a Y aesthetic. I want to have an X dimension in my visualization and a Y dimension. And in this case, I'm going to say, okay, for the X dimension, I have a variable in the MPG data set called displacement. It's called dispol, and a Y dimension called HWY, which is another variable. And when we do this, it will create the scatter plot. So I forgot to show you. So this MPG data set is a data set filled with data related to cars. So there's manufacturer, so Audi, model, displacement, which is the fuel, displacement by the engine, the year it was created, the number of cylinders, the transmission it has, whether it's front wheel drive, four wheel drive, the city highway mile per gallon. So it uses 18 miles per gallon in the city, the highway fuel efficiency, which is 29 miles per gallon, the this FL field, I forget what this FL field is, doesn't really matter. And then the class, it's a compact class. So the highway fuel efficiency and the city fuel efficiency are different because in cities, you start and stop a lot. And when you do that, it wastes some fuel. It's not as fuel efficient. So anyway, so going back to what I was saying, we created this scatter plot and we had that Y visual aesthetic and that X visual aesthetic. So we have the highway fuel efficiency versus the displacement. And we can see that as the displacement of the engine increases, it looks like the highway fuel efficiency also decreases. So if you were designing a car, then your objective was to have the highest highway fuel efficiency possible, you would want a lower displacement, apparently. I don't know. That's what it looks like based on this data. So let's say we wanted to represent a third variable here, and we were also curious about the class of the car. So we want to know how this highway fuel efficiency and displacement behavior operates broken down by a third variable, in this case, class. So unless we create a three-dimensional graph, we're going to have some other dimension to this. Well, we can have a color dimension. So we can define color equals class. And so now we can see it's that same graph, but it color-coded the class of car on the plot. So we could see that the relationships vary in different ways depending on what class of car. right? So for SUVs, that relationship actually doesn't really hold. It looks like the highway fuel efficiency and the displacement is more or less similar across, as we increase the displacement, the highway fuel efficiency seems to be generally pretty similar. So you can add a title to this now if you want. We're running out of time, so I'm going to just zip through this. So there's a function called GG title, and you can write, this is my title. You can write whatever you want, and it would create the title. Made a typo, but in this case, you can utilize the X lab and the Y lab to label the X axis and the Y axis. So it's not this ugly default that was the name of the field. We can rename it to be something more informative. And these labs, we can specify that we want to change the legend. So the color, that color dimension, we want that label to be class of cars, and we can create a title. So again, we only have a couple minutes because I want to answer questions, but I do want to get through just a little bit more because I think it's interesting. So for this next example, same exact thing as before. So we're going to use the ggplot library, and for the data, we want to use that data set I showed you. And we want to have the same code as before. So we have that scatter plot code. So this right here creates a scatter plot. But in this case, we want to still show that class variable, but we want to do it in a different way. That color dimension was a little bit confusing. So I want to see it broken down into different facets. And what does that mean? What do I mean by facets? Well, you'll see. So we can do something called facet wrapping. Specify that we want that class variable to be the facet with which we are wrapping our visualization. And when we do that, it will create these various facets of class, and it will, so what you're seeing here is it's graphing the highway fuel efficiency and that displacement, that same relationship, that same X and Y dimensions that we were just referencing with the scatter plot. Now it's breaking it down by class, though, so that those relationships become more apparent to us rather than having to discern the relationships via color. Now we can just do it spatially via these facets. And so this last thing is called facet grid. So it's a similar concept. But in this case, we want to, instead of having just one additional variable to the X and Y dimension, we want to have two more variables. So let's say we're interested in the number of cylinders and whether it's in the type of drive that it is, whether it's four-wheel, front drive, or rear drive. And so now we have four variables being depicted here. We have highway fuel efficiency, displacement, the number of cylinders, and what type of drive it is. And we've created these facets so that now we can see we can see how this highway fuel efficiency varies as we increase the displacement for each combination of the number of cylinders and drive. So in this case, to kind of drive this home, what I'm talking about here, we have a four-cylinder categorization of vehicles with four-wheel drive, and we can see that the highway fuel efficiency is more or less the same as you increase the displacement. It seems like it drops off dramatically. So there could be some, I don't know why that's the case. There could be some relationship there with, as we're increasing the displacement, maybe we're increasing the size of the engine and the weight of the car increases. I don't know. But we can see how these relationships hold across the various combinations here. So we can see that, we can see that in this case, it looks like the opposite relationship holds in this case, where four-cylinder vehicles with front-wheel drive, it's that inverse relationship where lower displacements are associated with higher fuel efficiency, apparently, and then it drops down. So I just wanted to show you this, we could keep going all day with this stuff, but just to drive home the point that this stuff's really not that convoluted. It just looks convoluted. So I hope that this illuminates that point a little bit, that, you know, all we're doing here is we're just telling R exactly what we want it to do in the language that it speaks. So we want to utilize ggplot, and we're going to use this particular data set, and we want to create this type of graph with these dimensions, and then we want an additional dimension. And so at this point, I've managed to ramble enough that we're kind of at the end here. So I'm going to move into questions here. So if you have any questions, go ahead and post it in the Q&A or the chat box, and I'll look at it. I know we don't have that many people here, so there may not actually be any questions, but. Okay, so it looks like we don't have any questions. First. So that, what I just showed you in R is available in a textbook. So this R for DS, R for data science, this chapter of data visualization will give you a more in-depth look at what I just did. And it will explain how the code works in more detail. And you can work through this if you're interested in picking up where we just left off here today. And it has additional breakdowns that I didn't have time to give you today. Whoops. All righty. Well, Brian, it doesn't seem like we have any questions today. So if you want to.
Yeah, that works for me.
Yeah, it works for me. Make